It's visual.
Yes, it's
Okay. Good evening, everyone. I welcome you to the third session of our programming course in C language. So in the last session, we have seen unit number 2. I'll just start my presentation. So in the last session, we have started with unit number 2. We have completed half of the unit and some concepts are remaining. We will first revise the concepts which we have studied in previous session, and then we will continue for today. So the agenda for today is we'll revise variables, data types, literals, constants, declaration and initialization of variables. Then today, the new concepts that we will see is what is program stack, what are keywords, identifiers, what are C libraries, macros, then what is meant by preprocessor directives. And now the next concept is very important, that is global, local, and static variables. You need to know what are the difference between these two variables. And then we'll revise scanf and printf, use predefined functions. So a variable can help you to handle memory. A variable is a memory space that you can store certain data in that space. It can help you in memory handling. So a variable in simple terms is a storage place where some memory is allocated, and in that memory you can store certain value. It may be a variable value or a constant value. There are different types of variables and they have different types of data types. So we have seen how to declare a variable. First, you have to write the type and then the name of the variable. For example, see at the bottom left of my screen, this is int a, means declaration. You are telling the compiler that in my program, I am going to use a variable a, which is of the type integer. And in your program, you're initializing that same variable a to the value 5. So first line is declaration, second line is initialization. You can do both these steps in a single line of code as I've shown here, that is int a equal to 5. So first the type, variable name, and then you can assign whatever value you want, and that value should be of the same type as you have declared the variable. Suppose it is integer a, then the value should be an integer. Now, in the previous session, we have seen character, integer, floating point, double, and void. Character, it can be a single alphabet or any number or a special character which you have to enclose within single quotes. For example, this is a single character. Then second is integer, all your whole numbers, that is 0 to infinity. You can store an integer. These values should not have any decimal point. Next, we have seen float, like 3.14. Such decimal values you can store. Then we have seen double, in which you can again store decimal values. Now today I'm going to demonstrate using a program what is the difference between float and double. We know that float has single precision and double has double the precision. So first of all, we'll see it through a program. And then there's one more. And then there is one more data type, which is string. But in order to understand string, you need to have some knowledge about arrays and some little knowledge about pointers, which we will see in future. So that time we will see string data type. Today we are also going to see Boolean data type. Now at the middle, what you can see are all the derived data types, such as array, references, pointers. And at the extreme right, you can see user-defined data types like structure, union, enumeration. These two we are going to see after a few lectures, not currently. So we know that character will occupy a single byte of memory. Integer will occupy 2 bytes if it is 32-bit, and if it is 64-bit, it will occupy 4 bytes of memory. Float will occupy 4 bytes of memory. double will occupy 8 bytes of memory in the computer memory. Now the difference between float and double. So before this, I've shared the screen of my dev C++ IDE. So we are going to see one program in which we will print the different data types and their values. See a first line, int a equal to 1. So a is an integer, float b, b is float, double c, it is of double data type. Then you have a character, the variable name is d, and you're storing the character a within single quotation. Now look at this commented part, int d equal to within quotation a. Now the data type is integer, but you're trying to store a character in it. So this will give you an error. It is type mismatch error. Then here integer, but you're storing float. Now this is allowed. If you store in an integer floating part values, it is allowed. But the problem is whatever fractional part is there. By fractional part, I mean 0.34. This value 0.34 is the fractional part which will not get stored in integer. So this is known as truncation. The fractional part, that is 0.34, will get truncated if you try to store decimal values in an integer variable. So what will be the output if I print the value of a here? The output will be, when I print the value of a here, it will, hello?
12.
12.
Yes, okay. Yes, correct, 12. Now, float b equal to 12. Here, what will happen is, it is an integer and you're storing in float. So the value, the output that will happen, that will get printed will be 12.6 times 0. Yes. So 6 times 0 means there are 6 digits after the decimal point. Here, this is only 12. So by default, it makes it 12.0. Now you can adjust how many digits to show after the decimal point. I'll just show it to you in a few minutes. Now, other than this basic data types, you have unsigned int. Unsigned means it is a positive number. Signed int means minus the whole number. Short int means a small range of integers. Now, integer has certain range from, we have seen in this table, right? Integer range and all. I'll just show you. See here. Integer occupies from -3 to 768 to 3 to 767. But short will occupy the same, or in certain compilers, it may occupy little lesser space. So here again, it is an integer value. Long int means you can store a large number. And short is again a small value. Now here I have not written short int. See here, I've written short int, long int, but here I've written only short. So by default, the compiler understands that I want to store an integer of the type short integer. So, but here I'm storing 9.67. So what will happen? 0.67 will get truncated. And what will get displayed? Only 9. Because by default, it is integer. Then you can have long int also. Long is a greater range for integer. Long is a still greater range for integer. You can also have long double, where you can store big decimal values. And one more important thing, long signed double. If you're using like this combination of long signed, it is not allowed in C language. Combination of such data types is not allowed. Now see, using printf in a better way. So here what we are doing, you can see %d here also and %d here also. So why I've used that? See my statement, integer variable %d occupies %d bytes in memory. So this %d is then a first %d. In place of that %d, the value of a will come. And in this second %d, the value of this will come. Now what is this? Size of, within parentheses I've written a. Size of parenthesis is an operator. Size of operator will return the size occupied by a particular variable. See, now a variable has a particular data type. So the size occupied by that data type will be printed at the output if you use size of a. A is the variable, size of variable. So this size of variable If it is integer, it will be 2. That 2 is this 2, the size 2 is also an integer. So I have used what here? %d. You use %d for integers. To display integers within printf, you have to use %d. So size of A is 4 bytes because it is integer, and that 4 will be written here. Similarly, floating point, see here, this float B variable is of the type float. So B, I've used %f, and size of B, float occupies 4 bytes. So size of B, what it returns to me? The value 4. 4 is again an integer value. So %d here again. Similarly, for double, what you have to use? %lf. LF stands for long float. Double is a long float. And the same thing, C and size of C. So the number of times you use percent whatever, no, percent whatever, the number of times you use percent, those many number of variables or values should be here after the quotation. Have you understood this?
Yes.
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 Okay. Okay. Now character, you have to use %c, and I'm printing it size. Then unsigned integer, you can use %u, or you can simply use %d also. Then for signed integer, you can use %d. For short integer, you can use %hi, or you can use %i, or %d, or %d. So one more thing, even for integer, you can use either %d or %i also. See this last printf statement. Here what I'm writing, %i. Integer, you can use %i or %d. Then for short, I'm using %hi. For long integer, what I have to use? %ld. L stands for long, D stands for decimal, which is for integer. In decimal numbering system, you have numbers from 0 to 9. So we are saying decimal here. Have you understood this?
Yes.
Yes.
Okay. Now we will run this program and let's see what is the output. So I'll just increase the font. See, a integer variable 1. Why 1 is getting printed? See here, this printf statement, integer variable %d. And in this %d, the value of A is coming. And what is the value of A? Value of A is 1. So integer variable %d, instead of %d 1 has come, occupies %d. Instead of %d, size of A has come. Size of A is 4 bytes. Why? Because A is integer. So integer variable 1 occupies 4 bytes in memory. So let this the output will be. Floating point variable 2.230000. So there are total 6 digits after decimal point. See, 1, 2, 3, 4, 5, 6. Occupies 4 bytes in memory. Double variable, again there are 6 digits after decimal, occupies 8 bytes. We know this. Character variable A. See here, when I was storing A in a character variable, I have to write single quotation A, single quotation. But when it is displayed at output, single quotation doesn't come, only A variable comes. Occupies 1 byte in memory. Unsigned integer variable, what was the value? 12. It will occupy 4 bytes in memory. Signed integer -12. Why signed? Because negative sign is given. Occupies 4 bytes in memory. Short integer will occupy again 2 bytes. Now long integer also occupies 4 bytes. See a long value. And short integer, see here, as I had mentioned here, short I equal to 9.67. But by default, it is integer if I don't specify int. So what has happened here? 9.67 has got truncated and only 9 can be seen at the output. And it occupies 2 bytes. Why? Short. So I hope you understood this program. Is there any doubt?
What's the difference between double and float?
Yes, the next topic I'm going to show you that difference. So just wait for a moment. Any other doubt?
No.
Okay. Now, as you have asked, I'll show you the difference between float and double. Now pay attention because this is important. Now, since you have not studied number system, I will explain what is number system, how much I was required. So see difference between float and double. So what is the difference between float and double is, now you consider one float variable and one double variable. Float x, double y. Okay, this is declaration. Now float will occupy 4 bytes, double will occupy 8 bytes. Okay, this we know. Now in x, suppose I want to store 0.7. In y, also I am storing 0.7. Now x is of float and y is of double. I am storing the same value, a decimal value, which is 0.7 in x as well as in y. Now, as I mentioned in my very first lecture, whatever high level language you write your code in, that is converted into machine level language, that is in the form of zeros and ones. 0 and 1, this number system, it is a number system, and this number system in which everything, each and everything can be represented in the form of zeros and ones, this number system is called binary number system. Why binary? Because there are only 2 digits, 0 and 1, where 0 is called a bit, 1 is also called a bit. So you need to convert this 0.7 into a combination of zeros and ones. How you will convert 0.7 into zeros and ones? You can either do it manually, but for you, the compiler will do it. So how the compiler does it or how you can do it as a human being, now I'm telling you. So 0.7, you have to multiply with 2. 0.7 into 2 is equal to 1.4. This 1 is the no integer part. This 1 you have to write here. And this is then a fractional part, 0.4. That you have to write here. See, I've written here. So next what you'll do, that 0.4 which has come from the previous calculation, 0.4 into 2 is equal to 0.8. Okay, 0.4 into 2 is 0.8. This 0.8, take the integer part here. You took the integer part 0 over here, and this 0.8 is there, no, that you have to bring here. Again, you have to do 0.8 into 2, that is 1.6. Again, take integer part 1, take 0.6 here. Again, into 2, 1.2. That is, you have to take integer part 1 and 0.2 will come here. Now, when will this stop? This will keep repeating, right? See, again, you've got 0.8 into 2, which is 1.6. That 1.6 you've got here. So again, this part will get repeated. Again, you'll get 0.8. Again, this will get repeated. So there's a very large combination of ones and zeros. Now, in this example, it is not terminating anywhere. It is recurring, repeating again and again. So in what case it will terminate? When you get 0.0 into 2. What will be the answer? 0.0. That time integer part will come here 0 and this will come here 0. So that time it will terminate when you get 0.0, because 0 into anything is 0. That time you can terminate it. So this is the way human beings can convert the decimal values into zeros and ones. Have you understood this part?
Yes.
Okay.
Yes.
So as you can, yes. And 1 minute. And the last time when you terminate, no, from there till the top in the reverse order, that is what you'll write. First you'll write 1, then you'll write 0, 0, 1, 1, 0, 1, and then you'll stop. From down to bottom, bottom up approach. From 1, 0, see 1, 0, 0, like that you have to write in reverse way. This is just an example, this combination. So now this length of the fractional part is very large. Now float occupies 4 bytes in memory. Double will occupy 8 bytes in memory. So this length of zeros and ones, no, this large value, you will store in float also, you will store in double also. So the float value will give you less accuracy, right? Because only limited number of digits you can store in a float variable. But in double variable, since it occupies more size, you can store a larger length of zeros and ones. Since you can store more zeros and ones here and less zeros and ones here, Where will you have greater accuracy? Can you tell me?
In double.
Double.
Yes, correct. And double. So double values are more accurate. No doubt you can store 0.7 in float also and double also. But what about the accuracy? Double will give you more accuracy. When you print your value 0.7 at the output, you will get better accuracy in terms of the digits after the decimal point. So is your doubt clear? What is the difference between float and double?
Yes, sir.
Yes, sir.
Okay, very good. Now I've demonstrated one program. I've taken the screenshot and pasted it here. We are going to demonstrate this program again in our dev C++ IDE. So I'll just open that program. See here, this program to demonstrate difference between float and double. See, this is float, this is double. A is of float type, B is of double type. So what I'm storing here, the value of pi, 3.1415 and so on. Here also I'm storing the same value. Now what is the syntax of printf? I told you to display size. Printf %d, because size is always integer, so %d or %i, and in place of %d what you want, size of the data type, or you can say variable. This is the syntax to display the size of a variable. So using these two lines, what will get displayed? Size of float. And here what will get displayed? Size of double. So if I run only this first line, can you tell me what output I'll get?
Size of
Three
the float.
point something something up to 6 digits in the float.
No, I'm saying, see, what I've written here, float. And what is the size of float? 4. So that 4 will come here. Okay, here I'm written double. What is the size of double? 8 bytes.
8.
That 8 is there, no? That will come here. Okay, so what will be the output of the first line?
Float size is equal to 4.
Yes,
4.
correct. And second line?
Double size
Float.
equal to 8.
Double size is equal to 8.
Yes, correct. Okay,
Yes.
this is the way you can print the size of a data type or a size of a variable of particular data type. Now, I'm printing the value of A and B. That is, I'm printing the value of A, which is float, and B, which is double. Now, as I told you, you can uh, define in your program that how many digits you want after decimal point. What is the syntax? You have done this already in Python. See, %f we used to write before. Now what I'm writing, %.16, that is 0.16. Means what will happen? In your floating point value, after the decimal point, you will get 16 digits. That means what you'll get? 3.141516. 6 digits you'll get if it is you don't give 0.16. By default, 6 digits you'll get to see. But if you want more digits or lesser digits, what you'll do? 0.16f. Similarly for double, you can either use LF here or you can simply use only F over here. So this way you can display the size of a variable and you can determine how many digits after the decimal point you want. So let's run this program. See here, what is the first line? Float size 4, double size 8. As you told me, the same output we have got. Then what we are getting? Float value, that is value of A, 3.1415927 something something. So see here, when I was storing the value in A, no, and see carefully, in the code editor, float A equal to 3.1415926. But here what you are getting? 3.1415927. After 92, I should get 6535 something something. But what I'm getting? Some other value. 74101 something. Okay. So how many digits accurate? 141592. Six digits after the decimal, you're getting exact value what you have stored. Okay. And after that, you're getting some other value. So this is the accuracy of float. Now see here, double, same value I've stored, 1415926535. Let's see what we have got for double. This is the value of B. What is the value of B? 141592653. See here, more accuracy. After 2, in my code editor, what I have? 6535. Here what I have? 6535. then 897, 897, 932 in my code editor, but at the output 931. So you see that accuracy. Double is giving you more accurate answer because it has stored a greater length of zeros and ones in its memory. Float has stored a small length of zeros and ones in its memory. So I think the concept of difference between float and double should be very clear by now. Is it clear?
Yes, sir.
Yes, very good. So now if you want, it is 0.16. If I do 0.6, let's see what is the value of a variable. See here, only 6 digits after decimal point. So this way you can tell the compiler how many digits you want after the decimal point. And this is how your accuracy will also get affected because of this. Okay, so float and double difference you have understood through program and theory. Now we have seen this, char occupies 1 byte, integer 2 or 4 bytes. When it is 2, can you tell me when integer will occupy 2 bytes? What should be the size of your operating system?
32-bit.
32
Yes,
bits.
32-bit operating system you should have. Only then integer will occupy 2 bytes in memory. See, whatever variables you use, all that needs to be stored in memory. And where it is stored in memory? At some memory location. So at that memory location, that space is then where it is stored. That space ka size will be 2 or 4 bytes. Similarly, float will occupy 4 bytes, double 8 bytes, long double 10 bytes. We have seen integers in the last class, float, character also we have seen. We have seen these examples. And just now through program also we have seen. So when I send you this PPT, you can see these examples. Okay. Now the next topic is Ascii value. So what is this Ascii value? First I've declared a character variable chr. Now I'm telling the user, please enter a character. So whatever the user will enter, that will get stored at the address of this variable chr. Now I repeat what I had said in the last lecture. All your variables are stored in memory at some memory location, and that memory location has an address. So what we are doing using scanf, we have to access the address first of that memory location. How we can access an address? Using this ampersand operator. Ampersand operator, and then you give the variable name. So at the address of the variable chr, you are storing the value entered by the user. And whenever you write ampersand variable name, this is known as referencing a value. Referencing means accessing the address of that value. Is this clear?
Yes.
Okay. Next, I've entered the value, the user has entered, and it is stored in what variable? Chr. Now, I want to display the value of chr. What will be the value of chr? The value that the user has entered. So you entered char %c. %c means what will come there? Value of chr. So I've written chr here. And if you want to display the ASCII value, that is the decimal value corresponding to your character value. Each character value is associated with some decimal value, which is called as ASCII value of that character. ASCII stands for, do you know the full form of ASCII?
No. American Standard Code of something.
American Standard Code for Information Interchange. Okay. Now, I'm using %d. Why? Because I said that ASCII value is a decimal, it is an integer value. So it is a whole number. So I'm using %d. And whose ASCII value I want to print? The ASCII value of the character which is stored in chr. Chr is a variable which holds a character, and that character ka ASCII value I want to print. So we'll demonstrate it now through dev C++ programming. So here is a list of all the ASCII values and the characters which I had explained last time. As I mentioned, American Standard Code for Information Interchange. Why we use this? Because we need to encode the characters in our electronics and communication domain. See, we transmit certain data, and that same data we want to receive. We don't want anyone to manipulate with the data in between. our value should be the same before it was transmitted. We have transmitted the value, and that same value should be received. There should not be any change in that value. So we have to encode that value at the transmitter, and at the receiver, we have to decode that value. It is like encryption and decryption. Means the people will not be able to understand that what is the actual value, and so they will not damage that value. Or maybe due to any noise in the communication medium, the value gets altered in wireless communication and so on. So you can use, this is the advantage of ASCII values. Okay, so now I'll demonstrate it in Dev C++. See this program to demonstrate ASCII value, how to print it. Char A, this is what, declaration or initialization? Can you tell me?
Declaration.
Yes. Then printf, enter character. The user will see the message, enter character. Then what? Whatever character is entered, that will get assigned to A using scanf. And that value is a character value. Even if you type 1 no, at the output, it is taken as a character. Then what will happen? Character is, in place of %C, what will come? The value of A. And its ASCII value in place of %D. So let us run this program. Enter a character. Suppose I enter capital A. I click enter. See what message I'm getting? Character is A and its ASCII value is 65. So just remember, capital A is 65. Let us check in our PPTs whether that same thing we have or no. See here, capital A, 65. Okay, same thing we have got. So the program is working correctly. Now you have studied for loops in Python. So we will see in C also how to do for loop. But I'm giving you an idea. If within a for loop, you enter this code. If this code is copied inside a for loop, and if you have certain iteration, no, you can print from the starting till the end all the ASCII values from A to Z. Okay, so when we learn for loops, this will be an assignment for you. Now you don't have to do it, but that time I will give you this assignment. Now let's get back. This is the same program that just now we wrote. Now next is constants. So a constant is what? A variable whose value will never change throughout the program. So constants are used for what? For mathematical constants, maybe for a bank balance. See, in banks, we have some minimum balance criteria. If you withdraw too much, you cannot withdraw beyond a certain limit. Suppose minimum balance in your account should be 500 rupees. So you cannot withdraw so much that only 300 rupees is left. You have to maintain 500 rupees minimum in your bank account. So 500 becomes a constant there. If you're implementing a bank management system in C or C++, the minimum balance 500 will be a constant value. So it is not necessary that only pi, velocity of light, and all that are only constants. You can define your own constants as per requirement. So how you can do it? I've told you already, hash define. You can either use that syntax, hash define, and then you have to give whatever variable name, and then write whatever value you want to store in it. So by this statement, what will happen? In V, the constant value 12 will be stored. This is called as macro definition of defining constants. So what happens in macro definition? In place of V, whenever you write V in your program, no, instead of V, what will come? 12 will come. So it replaces the actual meaning of the variable in your program. But there's another way to define constants. How? Using the keyword constant. What is a keyword? I've told you in my first session. Can you tell me what is keyword?
Which has predefined meaning.
Yes, exactly. Who has answered this question?
Pratik.
Pratik. Okay. Now, constant double. Double is the data type of pi, obviously, because 3.14 we want to store. So notice that we have used the keyword constant. So now I have used constant double pi equal to 3.14. Suppose on my next line or somewhere else in the program, if I write pi equal to 2.9, it will give me an error. Why? Because pi value cannot be changed. But here I'm changing it. So it gives me an error. Have you understood this?
Yes.
Yes.
Okay.
Yes.
So I would request others also, means whenever I ask a question, I'm finding that only few people are answering. So everyone can answer, not necessary that I will answer first or he will answer. If you know the answer, just tell it, okay? It will add up to how much you score by the end of this course. Now, there are different ways we can accept input or output. Printf is used for displaying the message at the output. Scanf to accept input from the user. Similarly, getChar and putChar. GetChar will accept a character from the user. PutChar will display a character at the output. Gets will accept a string. Puts will display the string. Okay. So we have seen printf, scanf. These remaining two we will see in future, not now. And I've included one more slide in which you can see which string formatting you have to use for which type of um, data type. 1 minute, I just should see this slide. So there are different types like short, char, all. For that, which format specifier I've written. At home, you can go through this slide when I share this PPT. So up till now, any doubts you have?
No.
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 So next topic is keywords. I've told you keyword means predefined meaning is assigned to that word and you cannot use it anywhere in your program. If you use it in a place where it should not be used, it will give you an error. So there are different keywords like, just a minute. So constant, I told you just now to define constant values. Integer, int, short, then unsigned we have seen, double, float, break and continue. You have seen this in for loop, I think so, in your course of programming and problem solving. We'll see this in
Yes.
our sessions also. Yes. So then you have signed, then you have void we have seen, else if else you have seen, means you already know it. Then for loop we know. Then what else, size of, to display the size of a particular variable or data type. Then goto is used to jump to a particular instruction. Then char we have seen, it is a data type. Return we have seen in functions. While loop ka while, this is the while. And if. So remaining we will see as we proceed in our sessions. Now identifier rules. Now we have already studied, I'll just revise these rules. Name of the variable or identifier should include letters, alphabets, lowercase, uppercase. Lowercase means small, A to Z. Uppercase means big, A to Z. Then digits from 0 to 9 and their combinations. And underscore is the only special character that is allowed in a variable or function name. You cannot use asterisk, question mark, dollar, hashtag in your variable name. Then you should start the name with an alphabet, and preferably it should be a lowercase alphabet. Means it's not compulsory to be a lowercase alphabet, but as per the guidelines or expectations, it is expected that you start with the lowercase alphabet. Then you can have underscore and then a combination of letters and digits underscore. Then you should not have any space in between the name of a single variable. No special characters except underscore. So if anyone asks you that which special character is allowed in a variable name, you should immediately say underscore, because that is the only one which is allowed. Then constants should be in uppercase. It is not compulsory again, but usually pi, then any other value is in capital letters, we write pi. Then keywords are not allowed as identifier names. So you already know the rules. I have revised the rules. So now you have to tell me among these examples, which one is valid identifier, which one is not valid. First, okay, I'll ask one by one, who means whenever I ask you, you have to answer me. So just wait a minute now. Tanmay, can you tell me the first example, AB12 underscore CD, is it valid or not?
Yes, it's valid.
Okay. Then Shubham Patil, can you tell me the second name is valid or not? Shubham Patil, are you there? Okay. Yashraj Patil, can you tell me the second variable name, is it valid or not?
Yes, it's valid.
Why is it valid? It's actually not valid
It's
because,
not valid. It's not valid.
yeah,
It
why?
doesn't start with letter, small letters.
Yes, correct, correct. So I'm keeping a track of who all are answering actually.
Yes.
So next I will ask Ruturaj Jadhav, the third variable name, is it valid or not?
No, it's not valid.
Okay. Then Ajay Patil, the third one, A, B, C, D, E, F. And there's a space in between them. Is it valid?
Valid.
There's a space between A, B, C, space D, E, F. Is it valid? So it's not valid actually because there's a space between the variable name. You cannot have a space. Next, Nachiket, can you tell me $12 hashtag AS, is it valid or not? Okay. Anyone else wants to try?
No.
Anyone?
Not valid.
Not valid.
Okay. Very good. Then see the last one, 1, 2, 3, asterisk, asterisk.
Not
Yogesh,
valid.
can you? Yes. Okay.
Not
Okay.
valid.
Correct. Yes.
Not
okay.
valid.
Yes. Correct. Okay. Now we'll get back to our theory part. So this slide is similar for your Hello World program. Just instead of Hello World, I'm typing C programming. So I've written what all happens in this program. You can go through it at home. Now we will see what is program stack. Just a minute. So see here, now whenever you want to execute a program, that program will be allocated some memory on your system. That memory which is allocated for your program, you can call it as applications memory. Now that memory, it is divided into different segments. So one of those segments, no, because each segment has different purpose. A particular segment in your memory will indicate certain aspect of your program. Like variables will be stored in a particular segment. Different instructions will be stored in some other segment. Some other information can be stored in some other segment. So among those many segments, one of the segment is stack. Program stack it is called. So in this program stack, I will explain to you in the lecture on Sunday, the first lecture, which was introduction. Stack follows last in, first out principle. Means what? Whatever comes inside last, that will be the first to move outside. For example, your book number 1. On top of that, your book number 2. On top of that, book number 3. On top of that, book number 4. So ideally, which one will come out first? Book number 4 from top of the stack. Then which one will come out? Book number 3, and so on. So whichever came in last, 4 came in last, it went out first. This is last in, first out. So in your program stack, first whichever function is called in your program, before that always one function is called, which is that main function, because execution of a program always will start from main function. So in your program stack, whatever memory needs to be allocated to main function, that will be allocated. See here, main function will occupy the stack, as you can see here. Now within main function, I want to call another function. So memory will be allocated to that function. Suppose I want to call function 1, then memory will be allocated to function 1. Now function 1, the body or the definition of function 1 is executed, then the control will come back to main. When the control comes back after the function definition is executed, the memory allocated to that function will get cleaned up. Means what will happen? Function 1 will leave the stack. Have you understood this? Hello?
Yes.
No.
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 No, okay, I'll explain again. See, execution of a program will start from main function. So whichever function you have in your program or whichever variables you have, all of them have to be stored in memory. Means memory has to be given to those
Oh, your voice is not audible.
Hello.
Hello, am I audible?
Yes.
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 Yes,
Yes.
sir.
I'm going to share my screen now. There was some technical error with my headphones. Is my screen visible?
Yeah.
Yes.
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 So we were seeing
Yes.
program stack. 1 minute. Yeah. So I'm explaining from the beginning. So you have understood that variables and functions have to be stored in memory. So some memory has to be given to them. This is called allocation of memory. So when some memory is given to them, they will be able to get executed. So your program will always start its execution from one particular function, which is called as main function. So that main function will enter the stack, means memory will be allocated to that main function. Okay, now in the main function, within the body of the main function, I'm calling one more function, and that function will now be allocated memory. So suppose I want to call func1. So func1 function will get allocated memory. So now the control will has already jumped through func1 function. The statements inside func1 function will get executed. Then the control will jump back to the function call in the main function. Okay, when the control jumps back to the function call in the main function, the memory which was allocated to func1, that will get erased. Means func1 will come outside of the stack. func1 will get deallocated from memory. So func1 came out of the stack. Have you understood now?
Yes.
Has everyone understood?
Yes.
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 Can I go ahead?
Yes.
Okay. Now, inside main function, after I've executed the statements of func1, so I've finished executing statements of func1. So within main function, the next statement will get executed. The next statement, the next statement. Then suppose after some time I want to call func2. Then func2 will get allocated memory. It will enter the stack. Okay. Then func2 ka statements will get executed. The program control will jump back to the main function. So func2 ka memory will get deallocated. Okay. And so func2 will get removed from the stack. Okay, have you understood it?
Yes.
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 Yes, sir.
Okay. So now the main, inside the main, all the statements have got executed. So what will happen? The memory which was allocated to main, that will also get erased. It will get deallocated. So finally, your program stack will be empty. And this is called the top of the stack. So have you understood program stack?
Yes. Yes, sir.
Okay.
Yes.
Now just wait a minute. So the next topic is global, local, and static variables. But since there's not much time, I won't start it today. That I'll start it next lecture. And now we'll go to the next topic, which is a very small topic, that is preprocessor directives. So I will explain it now. Preprocessor directive is nothing but your header files. See, I'll show you one program. See, in this program, what I've written, hash include stdio.h. This is the link section of a program. So it is also called as header file. Why header file? Because stdio is a file and its extension is .h. .h indicates that stdio is a header file. And this header file will connect your program with the C libraries. Means what will happen? Whenever you write hash include stdio.h, this statement will get replaced with the code which is present in stdio file. So in stdio file, there is certain definition, certain variables are there, certain functions are already defined for you, and all that code will get replaced with this line. So if you don't include this line, whatever code is in that library, or that file, you will not be able to access. So scanf, printf are the functions which you're just calling. You're not telling the compiler what you want to do when these functions are getting called. When these functions are getting called, there is certain meaning and that is going to get executed. But whatever is going to get executed, you have not defined it. Whatever is going to get executed is already defined. Who has defined it? When C language was getting developed, the C developers have already defined it, and you have to just use whatever they have created for you. So printf, scanf are just function calls, and they are already defined. So this is your header file. It is also called as preprocessor directive. Why preprocessor? Because before the actual processing starts, you have to do some things. That is called pre-processing, right? Pre means before processing. So pre-processing, in that your compiler will first convert the code in stdio.h to machine level language. Even the C developers have written the code in high level language. That is converted into machine level language by your compiler. Means everything gets into the format of 0 and 1. That will get compiled first, and you'll get zeros and ones of the stdio.file, and then whatever program you have written, that will get compiled. So before processing, pre-processing, this will get compiled, and then your program will get compiled and then executed. So this is called preprocessor directive. So I have written here that stdio.h is a 1 minute. stdio.h is a header file. Hash include indicates that it is a preprocessor directive. And it replaces the above line, that is std.h, that line, it replaces with the contents of stdio.h file. That is why you need to use this line before you can use the functions scanf and printf. You can also create your own header file. C developers have created their own header files. Similarly, you can also create your own header file. In your header file, suppose you're defining certain function, and if you include your header file in a program, then in that program, whatever you have defined in your header file, you will be able to use. I repeat, suppose you write a header file and you include that header file in a program, then in that program, whatever you use, you can also use whatever you have defined in your header file. And whenever you have a user defined header file, you have to how you have to include it, hash include within double quotations. your header file name .h. 1 minute. See here this statement, hash include your header file name .h within double quote. These header files within angular brackets. These header files within double quote. So this is preprocessor directive. Have you understood what I said?
Yes.
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 Okay. Now next is macros
1
definition.
minute.
Yes, yes.
So the double quote you said is for that if we create by our own.
Yes, if you create your own header file, then how you have to include it in your program within double quotations. But other header files which are already defined, you have to simply use
Yeah.
them how you'll do within angular brackets. Okay.
Yes.
Yes. Now macros definition. So this is your constants. I had said no hash define. Then you can write pi and 3.14 that value. So constants you can define. Other than constants, you can also define the functions. See, in hash define, what is happening? I'll show you. See here. Hash define C, and this is the speed of light. So what happens wherever you use C in your program, instead of C, the value 299792458 will come. So C is a constant value. So C in our program gets replaced with the value in its macros definition. So this is an example, hash define pi 3.14. So wherever I'm using pi here, see area equal to pi into r. Formula of area of a circle is pi r square. So instead of pi, the value of pi will come. This we have been doing in our programs. But you can also have a function in the form of macros. So how to do that? It is similar to calling a function. Now just tell me, have you studied functions in Python?
No.
Oh,
Oh,
you're not studied.
We are going to
Okay.
start.
Okay, no problem. So a function is a set of code or a set of statements which are written separately, and that particular block of statements you can call again and again in your program. So what happens if you don't use a function, then that particular set of statements you have to write again and again. Suppose at line number 1 you want to use that code, again at line number 10 you want to use that code, again at line number 15 you want to use that code. So again and again you have to write the code at those lines. Instead of that, put that whole code in a particular function, and that function you can call again and again whenever you want. So it will save time in your development, and all the logically related statements can be placed together. And there are many other benefits which we will discuss when we come to this topic in C language. So for now, you can call a function. Whenever you call a function, that code will come there and you can use it. So see here, hash define circle area is the name of a function. Okay, circle area is the name of a function, and you have to pass the radius to that function. So how do you write a function? Suppose the function name is A. Function name is A. You give opening bracket. You can pass certain value, give closing bracket, and semicolon. This is how you call a function. Calling function means what? You want to access the code of that function. You want to execute the statements written within that function. Similarly, circle area. Just a minute. So see a circle area. What you have to do there? It is a function. And in that function, you have to pass certain value. Now in area, what you need to calculate area? The radius. And whatever value is returned by that function, you can return certain values. Means what you can return from a function? The output of that function. Suppose you want to calculate the sum of two numbers. Then what is the output of that function? The sum of those two numbers. So that will be written here, whatever the output is. So how you are processing it? You have passed the radius to the function, and that radius you're accessing here. So how it happens, I'll just write over here. See here, whenever you write a function, suppose func, you're passing some value to here. So this is how you have to define a function. And in this function, suppose I want to calculate radius. So I will create a variable named a, and then I will initialize it. What I'll initialize it to? 3.14 into the value of r. Okay, and I've defined my function. I want to call it. So within your main program, what I will do, I will call the function. How I'll call? I have to write the function ka name, func, and within the brackets, I have to pass the radius. So how it will execute? When I say func 12, this function call, the control of your program will jump where? To this part, and it will enter here. So 12 is there, no? That will get assigned to the variable r, and that r you can use here. So I'm doing actually 3.14 into 12 into 12, and that 3.14 into 12 into 12, that result will get stored in a. So actually a should be a float type, and then this value of a, no, I can return. Within the function I have to write return a, and that value will come here. Okay, so basically what happens, that I have written a 3.14 into r, that you have to write here. So whenever you say circle area and you pass the radius, what will be the output? 3.14 into the radius into the radius. So here I'm passing 5. So instead of r, I'm getting 5. Have you understood this?
Yes.
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 Okay. So at the side here, I've given one example. See here. This is the last topic for today. stdio.h hash define pi. So instead of pi, 3.1415. Then hash define function name within brackets r, and you can access that r over here. And then how I'm using in my main function, I'm using float radius. See, float radius and area. So I'm asking the user to enter the radius. He will enter the radius. It will get stored in the variable radius. That value which is stored in radius, I'm passing to circle area function. So that radius I'm passing to circle area function. And instead of this line is there, no? 1 minute. Instead of this circle area, instead of this, what will come? 3.14, that is pi into r into r. So pi into r will come instead of circle area radius. So pi into r will get stored in area. And that area I'm displaying here through printf. So you have to first write circle area. 1 minute. So first circle area r, and then pi into r into r, and that radius will get assigned to area, and you can print that area. Have you understood, or should I explain once more?
Just I have a doubt that if we write the main function first and then defining the function later, will it be okay or will show error?
That is another concept where first you have to declare your function, call your main function, and after the main function, you can define whatever you have declared. So that we'll see in actual functions when we go to it. For now, you can remember this much. So in the next lecture, I will revise this macros and we'll see what is local, global, and
ସ୍କାନ୍
static
କରିଦବା
variable.
କଥା ଥିଲା ମଝିରେ ଆଉ
Till now, do you have any
Amrita,
questions?
mute yourself.
ସରି
Do you have any doubt till now? No.
no
Did you understand today's session?
Yes, sir.
Yes.
yes sir.
Yes.
Did you enjoy today's session?
Yeah, sure.
Yes.
Okay. So today also we won't have the quiz, but in the next lecture, we will finish our unit number 2, and that time I'm going to give you an assignment. That assignment you can take as a quiz itself, and you have to submit it on 17th March. Okay. So there are 20 MCQ questions in that. That will be counted as your assignment number 1. So it will contain the content of unit 1 as well as unit 2. So you can solve it and submit on 17 March. So today we won't have any quiz. So if you have any doubts, you can tell me. Otherwise, put your attendance in the chat box. Name, roll number, and division.
So today's PPT will be shared on the group.
Okay, I'll share it. No problem. Any other doubt? Start putting your attendance quickly. And after putting your attendance, if you don't have any doubt, you may leave this meeting. So thank you for attending today's session. We will meet on Tuesday now.
Thank you sir.
Welcome.
Excuse me, Bhaiya.
Yes.
The MCQ assignment you were telling, it should be in seriously or rough way we can do,
No,
or
no,
we
it
have
is
to maintain
MCQ.
it.
So you have to just it is a Google form. So in that you have to just select whichever option and you have to submit. Like how you attempt your quiz. It
Oh,
is just
acha,
a big
acha.
quiz. Like that.
Okay,
Okay.
understood.
Yes. Yes.
Okay, thank you, Bhaiya. Bye.
Yeah. Welcome. Bye.